Today we're going to talk about operation on sets on the KSSM syllabus chapter 4. You will be learning about intersection of sets, union of sets, and a combination of operations on sets. So let's get right into it. So we're going to talk about intersection first. Intersection, the symbol would be this, right? But we just go straight into the question then. So it is given that universal set X is an integer between 1 and 10. And set P is in a odd number, X is an odd number, set Q, X is a prime number, and set R, X is a multiple of 3. So before we go on, we need to list out what are already set, so we understand. So the overall limit, which is a universal set, is from 1 to 10, meaning that our limit, our number should be between 1 to 10. So this is something we got to remember, okay? So we got that down. We're going to go for set P. So set P, as they say, is an odd number. So odd numbers between 1 to 10 is 1, 3, 5, 7, 9. And then we'll go for Q. Set Q, we say X is a prime number. So what are the prime numbers between 1 to 10? So that would be 2, 3, 5, 7. Right, we got that down, and we will go for R. So R says that X is a multiple of 3. So we write down, what's the multiple of 3 between 1 to 10? That would be 3, 6, 9. Right? So we have already listed down the P, Q, R, the data sets in the P, Q, and R, and the limit, which is the universal set. So meaning if we would like to draw this out, for visual aid, we can do it like this. This would be the universal set, and P would be we're not going to draw it first, so we're going to skip this part first because we're going to learn to draw later. So I have to teach you the basics first before we can go straight into drawing. So yeah. So what is the intersection between P and Q? We'll do the first question first then. A1 wants to find the intersection between P and Q. So intersection is basically the similarities between P and Q, in other words, right? So when we'll focus on P and Q, we ignore set R first, right? So we find the similarities between P and Q, which is 3, 5, and 7, meaning the intersection between P and Q is basically 3, 5, 7. And then we'll go to the next question. What is the intersection between P and R? Again, let us remove the highlighter first for you guys to see clearly then. Oops. Okay. So the next one you want to look for is the intersection between P and R, which is this. So we'll ignore Q right now. So what's the similarities between P and R? 3 is repeating, and 9. So in other words, the intersection would be 3 and 9. And the third question. Right. So we have the third one is the intersection between Q and R. Q and R. So we also do this, Q and R. So again, right now we ignore P, and what's the similarities? It's 3, and that's all. It doesn't matter how many number of elements you have. It's just to understand what's the difference. You can have one, you can have none. It doesn't really. There's no actually that is not a criteria for it actually. So the fourth one, we will search for the intersection between P, Q, and R. This would be harder because they want the intersection between P, Q, and R. So let's go for this. So we have to look for the similarities in 3 of this. So what is the similarities? I would say that is 3, and that's pretty much it. Okay, so remember just now I mentioned that we should draw the Venn diagram. So understanding these numbers now, we can easily draw a Venn diagram, which is like this. So set P. So we know that there is an intersection between P, Q, and R, so it will look pretty much like this. And this would be number 3. So let's say I name this P, Q, and R. I want to know I know the intersection between P and Q, right? Which is here. So it's 3. Whoops. 5, 7. It's a little bit small, sorry. And the intersection between P and R would be 3 and 9. So 3 and 9. The intersection between Q and R is only 3. So that would be empty. Alright, so let's fill in the remaining numbers, which is 1. For Q, we still have 2. So 2, 3, 5, 7. Right? And R, we have 3, 6, 9. So there you go. This is how it will look like with it if you draw it in a Venn diagram. Right, so the next one, we want to determine how many number of elements are there in the following sets, which is this basically, right? So, right, let's move it over to the side and determine the number of elements. So what is the number of elements? Take a sample for this P intersect Q. How many number of elements would there be here? Would it be here? So it would be 1, 2, and 3. So basically, the number of elements between P and Q, the intersection of P and Q, would be 3. Okay, continuing, the intersection between P and R, 3. Whoops, would be 2, because there is only 2 elements here. Right? Similarly for the rest, I'll just make it quick, and P intersect Q intersect R would be 1. Alright, we'll move on to the next one. This would be an example for visual aid to let you understand what is intersection basically. So intersection between P and Q would be here. Intersection between P and Q for this diagram would be here, because which is also similar to Q. So in other words, P intersect Q is also equals to Q. This symbol here would be subset, meaning that P intersect Q, which is Q, is the subset of P. Because in other words, Q is also inside of P, so it's a subset of P, right? So P intersect R basically is P and R, and here's the intersection. It is not P intersect Q and R, because if you want that, the intersection you will get is here, not here, right? So yeah. So the next one we'll look at is we'll just continue then, okay? The intersection of J and K, the J and K. So if you look at it, it will be 5 and 3. Okay? The intersection between J and L would be here, which is L. If you look at this one, you can just look at the previous visual aid we produced for you. So that's for easy understanding. So what's the K intersection with L? K intersection with L would be 5 only. Alright? And what's the intersection between J, K, and L? Let's look at this. It will be hard to see, but I can draw it out for you. So basically, K is this, L is this, and J is this. So the intersection is here. probably made it worse, but yeah. So 5 is the intersection between J, K, and L. It's just a combination. So we'll look at the next question then. The numbers on the dice, we understand that is 1, 2, 3, 4, 5, 6. And then set B, we have even numbers of the dice. Even numbers would be 2, 4, and 6. Right? Let's write that down. 2, 4, 6. And then we have set C, which is 7, 8, 9. Alright, so we can continue with the question then. List all the elements of the following intersection. So intersection A and B. What's the intersection of A and B then? We'll look at this, and there's the similarities basically. 2, 4, 6. 2, 4, 6. Right? So that would be our intersection of A and B. 2, 4, 6. Right? Then we'll move to the next one. What's the intersection between B and C then? We run B and C. Is there any intersection? No, there is not any intersection. That was a trick question. So there isn't any intersection between there isn't any intersection between B and C, because you can see that B is 2, 4, 6 and set C is 7, 8, 9, which is, there is basically no similarities. So in this situation, there is two forms you can write for no elements, which is by this shows an empty bracket, and or this. So it would be great, and that's all. So what the next question says that what is the intersection between A and C then? A and C, is there an intersection? Similarly, there is no intersection, so that would be no intersection. Okay. So now they want us to draw a Venn diagram to represent A, B, C. So we understand that B and C does not intersect, A and C does not intersect. So we understand that C is excluded in a way. So let me draw this right now. So this would be set A, and then set B, and this is set C, if you could understand, right? So set A, intersection between set A and B would be 2, 4, 6, such from the A1, and then 7, 8, 9 here, and then the remaining would be 1, 5, and 3. So the next question in B1, they want the intersection between A and B, which would be here, right? And the next question, the intersection between B and C. But if we look to the question A2, we will understand that there is no intersection. So we'll just leave it blank and just say that they do not have any common elements, right? So one more question. It is given that A... this is the same question. It's okay then. We'll move next. So now we'll talk about complements. Complements is basically like the opposite of what you want to search for. So just now we searched for intersection, right? So the complements of intersection is what is not an intersection, if you get what I mean, right? I'll show you with an example then. So right now our limit is 1 to 8, and then set A is here, set B, and set C. List all the elements and state the number of elements for the following sets. So in order to understand the complements of an intersection, we need to understand what is the intersection between A and B first. So here I'll write then the intersection of A and B. If we can check in our similarities, which is similar to the front on what we learned in the front, would be 2, 4, and 6. So our whole limit is between 1 and 8, right? So right now I want the complements of intersection A and B, which which would be 1, 3, 5, 7, 8. Because in a way, this intersection, this complement is the opposite of intersection. So the intersection is 2, 4, 6. I want anything that is not the intersection of A and B, right? And if we want to understand the number of elements of the complements, we can just press right and 1, 2, 3, 4, 5. Oops, that would be 5. Okay. Right, then let's go on again. We'll start with question B then. What is the intersection between A and C then? The intersection between A and C, if we look at here, A and C, will be 1, 2, 3, and 4. So I want anything except the intersection of A and C, which is the complement of intersection A and C. So that would be 5, 6, 7, and 8. And the number of elements of complement would be 4. Again, one more question. We'll do the intersection between A, B, and C. So what's A? 1, 2, 3, 4, 5, 6. B, 2, 4, 6. C, 1, 2, 3, 4. So the intersection would be 2 and 4. Right, now we'll look for the complements. The complements would be 1, 3, 5, 6, 7, 8. The number of elements then would be 6. Would be 6, right? It's quite ugly. Okay, so let's go try another question. This would be a lot more, a little bit more harder because it's not numbers anymore. It's strings and it's characters. So I'll make this slower. So we have the universal set, which is the Scouts. A lot of words. P would be this, and then Q and R, right? So in order to let us simplify this, let's just give abbreviation for each and every one of it because it's quite long. Scouts, I would use S, M, H, F, H, I, badminton, police car, cadet, right? So this is just for easy understanding, but in exam you have to list it out fully, okay? Alright, so list all the elements of the following sets, the complements of P intersect R. So what is the intersection of P and R? Right? Intersection of P and R, we'll focus on these two, would be Scouts, and that's all. Right, so the intersection of P and R is Scouts, but what I want is the complements of P intersect R, which would be the others, which is this. So in other words, the complements of the intersection P and R would be mathematics, hockey, football, history, badminton, and police cadet. Right? Next question. Then we will want to understand the complements of R intersect Q. So what's the intersection between R and Q then? The intersection of R and Q is history. And that's all. So what we want is everything except history. So the answer for this complement of R intersect Q would be Scouts, mathematics, hockey, football, badminton, and police cadet, which we will not write history because history is the intersection between R and Q, and I want the complements, which is the opposite, right? Next question. I want the complements of intersection P, Q, and R. If we look at this again, what is the intersection between P, Q, and R? I don't think you can find any because there is no intersection between P, Q, and R, right? So what happens now? What is the complements of P, Q, and R? Of course, that would be the whole entire set. So the complements of intersect P, Q, and R would be Scouts, Mathematics, Hockey, Football, History, Badminton, and Police Cadet. And there you go. It's really similar to the numbers. It's just a little bit longer, so it might be a little bit more confusing. But if you understand the concept, you get the hang of it. So they want us to draw a Venn diagram for the following, to answer the following question. Okay, cool. The sets P, Q, R and shade the region that represents each of it. Okay, cool. So we understand that there is an intersection between P and R and Q. So right. Our circle will look something like this. I'll make it over so I have a little bit more space because it's all words, right? And the way I'll write down here is Mets, Scouts. This is from the previous question that we did. We understand the intersection, right? I'll just write it out now. Okay, so right now they want us to shade the following, okay? So they want us to find the complements of P intersect R. So we understand that the intersection of P and R is Scouts, so that would be everything except Scouts. So that's for question 1, right? For question 2, R intersect Q. We understand that R intersect Q is history. So what's the complements of it? The complements of it is everything except history, right? So that would be shading all this except history, because that history is the R intersect Q. Yeah. So that's for question 2. And question 3, we understand that there is no intersection between P, Q, and R, right? So basically, your complements would be the whole entire thing, right? Okay. And this would be an illustration to show you what's the difference between P intersect R, which I showed you on the previous slide, and this, which is the complements of the intersection. So we do some real problem-solving questions then. A total of 140 Form 5 pupils are given an opportunity to attend intensive class for history and Bahasa Melayu. 65 chooses Bahasa Melayu, 70 people history, 50 people choose Bahasa Melayu and history. So calculate the total number of people who attend the intensive class. So we have all this information given to us, and so right now I'll teach you how to tackle this question using visual aid, which is the Venn diagram, okay? So we understand from here that 50 pupils chose both Bahasa Melayu and history. So we did that, BM and history. So that would be 50 people here. And then 65 people chooses Bahasa Melayu, meaning that this circle has 65. But do take note that 50 people did both Bahasa Melayu and history. So you have to subtract 65 with 50 to get 15. So meaning the combination of 15 and 50 produces 65, right? That means that 65 people are taking Bahasa Melayu, right? And then over here, they told you that 70 people chooses history. So history, there is 70. So meaning 70 subtracted by 50, you get 20. And then you get the remaining, right? Because if you count it, 70 plus 65. Sorry. And then you get the people that took the intensive class, which is 85. When you combine all this, that means adding up 15, 50 and 20, you get 85, which you got your first answer. That is the total number of people who attended your intensive class. And then after that, you want to know who did not attend the intensive class, right? So understanding from the paragraph, you see that 140 from 5 pupils are given the opportunity to attend. Meaning there is 140 people, but then again, only 85 joined the intensive class. So the remaining would be 140 minus by 85, which is 55. So your remaining people who did not attend any class would be 55. So there you go. So we'll try the next question again. This is another problem solving question. So a total of 200 university students took part in a survey on the use of technological devices. The result of this survey shows that 155 students have mobile phones, 90 students have laptops, 37 have tablets, 4 both tablets and laptop only, 50 mobile phone and laptop only, 5 mobile phone and tablets only, 83 mobile phones only. That's a lot of information, but it's useful information, okay? So we understand that based on the number of based on the information given, we have 3 sets, which is mobile phone, laptops and tablets. So we draw. Should we do 3 circles then? Alright. So label this as mobile phone, laptop and telephone. So based on this, we have 50 people that have mobile phone and laptops, 50. And then laptops and telephone would be 4. This would be 5. And so we understand that 155 students have mobile phones. So if we subtract 155 together with 50 and 5 and x, what we get is 83. Right? Because this is the number they gave. So 83 is here, and we understand that the total number of people that have mobile phone is 155. So how do we find x then? So we can find x by subtracting 155 together with 83, 550. So in other words, 155 minus 83 minus 50 minus 5 would be x. X would be equal to 17. Right? So we have that number now. See, because we have a lot of unknown numbers like x, y, z, because we aren't given that much information on these parts, right? And we have to understand that there are people without phones, so that's another unknown variable. Oops. So that's another unknown variable, which is p. So we'll look for it slowly then, because we have all the information, so it allows us to look for it. Another thing is we know that 90 students have laptops, right? So if we want to, we have x now, and we want to determine y, we can subtract 90 minus 50 minus 4 minus x, which is from here. We'll just drag it down, and it will be equals to y. So y would be 19, right? And now we have one z. We understand that 37 students have tablets, right? 37 students have tablet, meaning that 37 minus 5 minus 4 minus x, which is 17, that we know just from the first question, would be we will get Z. So Z is 11, right? And then we understand that the total there is 200 university students, but when you add up all these numbers, it doesn't reach 200. So meaning that there is some people without mobile, laptop or telephone, right? So we want that number too. So that's in order to answer our question, we need all the information we can get. So to get P, we get 200 minus 83 minus 50 minus 5 minus 4 x, y, and z. So we'll get P. And in the end, we get 11 for P. So what's the question now? The total number of people who have all three technological devices, which is X, which also is 17. Because the number of people who have all three technological devices is the intersection here. Okay, that's annoying. You know what? So the next question is the total number of P students who do not have any of the technological devices, which is the answer that we looked for, which is P. So because P is equals to 11 because they do not have any device and they do not have a mobile phone, laptop or a tablet, right? Next question. Alright, so we reach the next subtopic, which is union. Union can be thought of as plus, right? And the symbol is U. Remember that the symbol of intersection is this, and the union is the opposite, right? So this is some visual aid. You can refer to it later. So we'll try a question. It is given that the set P is factors of 24, Q multiples of 3 that are less than 20, and R multiples of 4 that is less than 20, right? So we're similar to the intersection. We'll just list it out first. P is a factor, are factors of 24. So we just list it out then. 1, 2, 3, 4, 6, 8, 12, 24. These are factors of 24. Okay? So Q, the multiples of 3 which are less than 20. 3, 6, 9, 12, 15, 18. Right? And set R would be the multiple of 4 which are less than 20. Again, we'll write this out. 4, 8, 12, 16. Oops. So we want the union of P and Q. When we talk about union, we want to combine everything together. So for intersection, we want to find the similarities, but union, we want to combine everything together. So basically, P union Q would be this and this. In other words, P union Q would be 1, 2, 3, 4, 6, 8, 9, 12, 15, 18, 24. Okay? So it's a combination of all.